Okay, so this is our second example. Again, just pause this and have a quick read through what it's asking you to do. Okay, so this one is a little bit trickier in terms of the part A, you're just finding the coefficient of friction straight away. So there's a few more steps to do in the part A. I've enlarged the image here so I can just add my forces straight to the diagram. So again, adding our forces on wherever the ladder, or in this case it actually is a ladder, touches a surface, add a perpendicular normal reaction. So we've got one here and one here, and then add on your other forces. So we've got the weight of the ladder, it's uniform, so that acts at the midpoint here, and that's mg. Now we've also got this weight at C, which is of mass 2m, so that causes a force of 2mg. And then we've got friction again. So again, because the reaction at B is to the left, the frictional force must be to the right. And here it makes a bit more sense. The way to visualize this one is if you actually had a ladder resting on a wall like this, the top would be sliding down and the bottom would be sliding away from the wall, which is why friction acts in the opposite direction. Okay, so that's all our forces, so we're going to go straight into the working. And again, it's the same three things: up equals down, left equals right, and moments about a point. So again, if you just think through them and decide which order you want to do them in, you see left equals right gives us mu RA equals RB. Fine, but we'll come back to that one. Up equals down is a pretty easy one, so we'll start there. When we say up equals down, you can see that RA simply equals 2mg plus mg, 3mg. Next we'll take moments. Again, we'll take moments at A, and that's because the frictional force and the reaction at A both have a line of action through A, so they'll both be removed from our calculation. So clockwise moment first, in the same way as before, we've got a force of 2mg, and then the perpendicular distance from A to the line of action of this force is A cos 60. And we've got another force which is mg, the weight, and in the same way this one though is 1.5 A cos 60. Okay, and then the counterclockwise moment is provided by the reaction at B. So for this one, the force is RB. And what's the perpendicular distance from A to this force? Well, it's actually just this vertical distance here, which is the same as the height from the top to the bottom. So in this, and that's because the line of action of the force you can extend along here, and then you're looking for this distance. So this is going to be 3A sine 60. Okay, well, that's not too bad. We can divide everything by A, and then we can see that RB is going to equal this left-hand side divided by 3 sine 60. So it is still going to have a factor of mg in it. So what I'm going to do on my calculator is I'm going to do 2 times cos 60, add 1.5 times cos 60, and then I'm going to divide that by 3 times sine 60, and that tells me 7 root 3 over 18. But remember, that's how many mg's we've got. So finally then, to work out the coefficient of friction, we can do right equals left. So here we can see that mu times RA equals RB. Now we know that RA is 3mg. we go. So we can divide both sides by mg, and we can see that mu equals 7 root 3 over 54. Now that's an exact value. I would suggest never giving exact values in mechanics questions just in case. Here it would be fine, but if you just always give a decimal, then that's probably best. So here 0.225 to 3 significant figures. Now the reason I've gone for 3 significant figures here is because the g actually cancelled out, so our working is independent of g, so you should go to 3 significant figures. Then for part B, it says how have we used the assumption the ladder is uniform. Well, when we model something as being uniform, what that means in mechanics is that the weight acts at the midpoint. So all that means is the weight of the ladder acts at its midpoint. There we go, and that's another question done. So we've got one more example to look at.